Dear students, welcome to our lecture 3. Topic of this lecture will be trigonometric substitutions. So here we want to see how can we integrate involving these types of radicals. For example, if your integral involve these types of radical a square minus x square, then how can you integrate it? If your integral involve these types of radicals, you need to substitute x by a sin theta, and if your integral involve these types of radical, you need to substitute x by a tan theta, and if your integral involve these types of radicals, then you need to substitute x here by a sec theta. And there is some restriction on theta. Theta should be within minus pi by 2 to pi by 2 and minus pi by 2 to pi by 2 for the tan theta, and for the sec theta this is the restriction on theta. So let me review again. How can you remember this? If you have a negative sign before x square, then you should use a sec sin theta, and if both of them are positive, then you should use tan theta, and if positive sign, the preceding sign of x square is plus, then you need to use x equal a sec theta. So let's try example 1. In example 1, you see your radical involve 4 minus x square. So your substitution should be x equal 2 sin theta, because a square equal to 4, so a equal 2, therefore x equal 2 sin theta. So dx equal to cos theta d theta. So let us substitute this dx here, and x square equal 4 sin square theta root 4 minus x square equal 4 sin square theta, and 4 sin square theta, you can take this 4 outside of this radical, so it will be 2, 1 minus sin square equal cos square, and square root of cos square equal cos theta. So you can cancel 2 and 2, cos theta and cos theta. Finally, you will get 1 by 4 cosec square theta d theta, and we know integration of cosec square theta equal minus cot theta. So it will be minus 1 by 4 cot theta plus c. Now the question is, how can we substitute this theta into x? To do that, let us consider a triangle ABC where sin theta equal AB by AC. So from here we see sin theta equal x by 2. Therefore AB equal x, and instead of AC we can write 2. Another line BC will be square root of 4 minus x square by using Pythagoras law. And cot theta equal, we know BC by AB. So BC equal root 4 minus x square, and AB equal x plus integrating constant c. So this is your answer. Now let us try example 2, which is a definite integral. We want to evaluate the same integral from 1 to root 2. In that case, there are two methods. Either you can just consider first this integral as an indefinite integral, then evaluate it like before what you did here, and finally you can replace the limits of integration here in this result. So this result, we don't need to use c for definite integral. 1 by 4 root 4 minus x square divided by x. So first replace upper limit for x, so it will be 4 minus 2 divided by root 2 minus lower limit, which is 1, so root 4 minus 1 divided by 1, which is equal minus 1 by 4 root 2 divided by root 2 minus root 3. which is equal minus 1 by 4, 1 minus root 3, which is equal 1 by 4 root 3 minus 1, and this is the answer. Or you can evaluate this integral by another method where you don't need to evaluate first the indefinite one, just directly you can integrate it by using this substitution. So let's say x equal to sine theta, therefore dx equal to cos theta d theta, and at the same time you can evaluate the corresponding value of theta. So when x equal to root 2, then what is theta, and when x equal to 1, what is theta? If x equal root 2, then we will get root 2 equal to sine theta, which is equal sine theta equal 1 by root 2, which is equal sine pi by 4, therefore theta equals pi by 4. And when x equal 1, sine theta equal half, which is equal sine pi by 6, so theta equals pi by 6. And now you can replace this result here. Instead of 1 you should write pi by 6, and instead of root 2 you should write pi by 4, and dx will be 2 cos theta d theta, x square will be 4 sin square theta, and again this term will be 2 cos theta like before what we did. So you can cancel these things, which is equal 1 by 4 integration of 1 by sin square means cosec, which is equal minus cot theta pi by 6 to pi by 4, which is equal minus 1 by 4 cot pi by 4 minus cot pi by 6, which is equal minus 1 by 4, and cot pi by 4 equal 1, cot pi by 6 equal root 3. So this equal 1 by 4 root 3 minus 1. This is the answer. So let's try example 3. Find the area of the ellipse x square by a square plus y square b square equal to 1, and we know it's a standard ellipse, and here a should be greater than b, so that we can consider the major axis. This one is the major axis and this one is the minor axis, and the distance from here, from the origin to the vertex, is a. So if we evaluate 0 to a y dx, then we will get the area in the first quadrant, and if you multiply this area by 4, you will get the whole area of this ellipse. And y equal, from this equation, y equal b square by a square 1 minus x square, a square minus x square, plus minus root, this equal plus minus b by a root a square minus x square. But since we are calculating area in the first quadrant, so our y should be the positive one. So this equal 4 0 to a, y equal to this b by a root a square minus x square dx, which is equal 4b by a 0 to a root a square minus x square dx. Now you can evaluate this one, the integral, like before what we did, and here your x should be a sin theta. So the area is equal 4b by a 0 to a root a square minus x square dx. Now let's say x equal a sin theta, therefore dx equal a cos theta d theta when x equals 0, theta equal 0, because sin theta equals 0, and when x equal a equal a sin theta, therefore sin theta equal 1, which is equal sin pi by 2, so theta equals pi by 2. Therefore this integral becomes 4b by a 0 to pi by 2 root a square minus a square sin square theta, and dx equal a cos theta d theta, which is equal 4b by a integration from 0 to pi by 2 a cos theta d theta. You can cancel this a and this a and take it out of integration, so you will get 4ab 0 to pi by 2 cos square theta d theta. And if you know 2 cos square theta equal 1 plus cos 2 theta, so I need to divide it by 2, 4ab divided by 2, so that I can write here 2 cos square theta d theta, and this equal 2ab 2 cos square theta d theta is equal 1 plus cos 2 theta integration from 0 to pi by 2 d theta, and this equal integration of 1 theta plus integration of cos 2 theta sin 2 theta by 2 0 to pi by 2, which is equal to 2ab. You replace pi by 2 plus, if you put pi by 2 here, then it will be sin pi, and you know sin pi equals 0, and if you put 0, theta will be 0 minus 0, so the answer will be pi ab. So this is the answer. So the area of an ellipse is this, pi ab. If you know the length of major axis and if you know the length of minor axis, then by using this as a formula you can easily evaluate area of an ellipse. And now let's try another example, which is example 4. Find the arc length of y equal to x square by 2 from 0 to 1. Let's say from x equal 0 to x equal 1. Here we need to use a formula of arc length, which is L equal x equal a to x equal b 1 plus dy by dx whole square root dx. We know this formula calculates arc length of a curve y equal fx. So here we are given y. and given y equal x square by 2, therefore dy by dx equal x. So we can replace it here, and we need to calculate arc length from 0 to 1. So the lower limit will be 0, upper limit 1, 1 plus x square dx. So you can easily calculate the arc length of this function by letting x equal a tan theta and a equal to 1. So tan theta, therefore dx equal sec square theta d theta, and when x equal to 0, theta equals 0, when x equal to 1, theta equals pi by 4. So this integral becomes 0 to pi by 4 root 1 plus tan square theta sec square theta d theta, and which equal 0 to pi by 4, 1 plus tan square equals sec square, and root sec square means sec theta into sec square theta d theta, which is equal 0 to pi by 4 sec 3 theta d theta. Now we can use reduction formula. As you know, by using reduction formula of this one, we can write half sec theta tan theta plus half ln absolute value of sec theta plus tan theta. So this is the integration of sec 3 theta by using reduction formula, and now you can replace your limit. So if you put the upper limit, half, you will get half sec pi by 4 equal root 2, and tan pi by 4 equal to 1, plus half ln root 2 plus 1 minus, if you put 0, then it will be this one will be tan 0 equals 0, but here you will get ln half ln sec 0 equal what? 1 plus 0, and again ln 1 equal to 0, so you can cancel this one. So the answer will be 1 by root 2 plus half ln absolute value of root 2 plus 1 using your calculator, which will be 1.148. This is the answer. So let's try another example, example 5, and evaluate integration of root x square minus 25 by x dx, where x should be always positive and greater than 5. So here your substitution will be x equal 5 sec theta, because a square equal 25, so a is equal to 5, and I think remaining part you can try in your apartment, and the answer of this problem will be root x square minus 25 minus 5 sec inverse x by 5 plus c. So we want to also know integral involving x square plus bx plus c. How can we integrate an integral involving x square plus bx plus c? Let's try this example. Integration of 1 by x divided by x square minus 4x plus 8 dx. So if your integral involve x square plus bx plus c like term, then first you need to make this one as a square term. So which will be x square minus 2 into x into 2 plus 2 square plus 4 dx, which is equal x by x minus 2 whole square plus 2 square dx. And let us substitute x minus 2 by z. Therefore dx equal dz and x equal z plus 2. So this integral becomes z plus 2 divided by z square plus 2 square and dx equal dz. Which is equal integration of z by z square plus 2 square plus 2 by z square plus 2 square dz. And this equal, derivative of z square equal 2z, z square plus 2 equal 2z. So if you put 2 here, you need to divide it by half. And we can use this formula, ln z square plus 4, and you don't need to write absolute sign here because z square plus 4 always positive, plus 2 into integration of 1 by a square plus x square equal 1 by 2 tan inverse z by 2 plus c. So finally you need to replace z by z plus 2, z equal x minus 2 whole square plus 4 plus tan inverse x minus 2 by 2 plus c, which is equal, or you can put your answer here. So if your integral involve x square plus bx plus c like term, then you need to first make it a square term, then you can easily evaluate it by using the formula what you know. So that's the answer of this problem. So let me put some homework for you. You can try in your apartment. So that's the end of this lecture. If you have any problem regarding homework, you can text me. I will happily try answer your problems or any questions, and stay connected with us for the next lecture. Thanks for watching.